Well, hello again. Just want to say thanks for watching. I hope these different videos that I'm putting out there have helped you as far as getting your machine ready to go and get it on the track. I haven't put anything out for a little bit. I haven't been doing much building. About all I've really been doing is maintaining my machines and keeping them on the track. However, I am building a new front end for a couple people that are trying to get some machines together. So it dawned on me that when I did all those lessons on front ends, most of those were put together. And so since this one I'm building from scratch, I figured I'd take a few minutes and video it and explain what I'm doing. So what you see here is everything involved with building a front end. It doesn't look like much, but that's because there isn't much. So all I've got is some 1.5 inch square tubing, some 2-inch square tubing, some 2-inch flat bar, and some 1-inch flat bar, and some bolts, 5/8, 1/2 inch. So there's not much to it. This will be heim joints too. I'm going to add heim joints to this. So this will have heim joints on the bottom, which will allow it to caster and camber, and then I'll do rod ends and adjustable tie rods. So anyway, all said and done, all this material that you're going to see here, the metal itself was about 10 bucks at we have a local metal supplier. The heim joints I pick up locally. They're about $10, and so there'll be 2 of those. And then my rod ends and rods, I'll pick those up as well, and they're going to cost me about $10 per side, and that'll be 2 of them. So all said and done, around $50 roughly, and I'll have this front end put together. So now you can buy these. There are people that are out online that will build you a front end. We had a racer that did that. I think he paid $200 for it. So I guess it's just what your preference is. For me, I'd rather save the money and build, you know. So anyway, I do want to emphasize this axle beam is only 1/8 inch steel. It doesn't have a lot of stress on it. I mean, it has some stress, but not a lot. But the rest of these parts are 1/4 inch, and I would tell you to definitely use 1/4 inch thick. I don't know if you need to go much thicker, but I would definitely not go thinner. We've had racers do that, and it just didn't work out. Parts started bending, and tires were rubbing, and steering got out of whack. So I've been using 1/4 inch. I've been running these front ends for about 5 years, and I haven't had any issues with them. Now, this is just 2-inch square tubing, and you know, you could bend this and you'll see what that part becomes. I found that it's just easier to buy it. I'll take my chop saw and I'll cut this outer edge off. So the reason I do that is it's square, it's even, uniform, and it's easy. Okay, there they are. That was fast, huh? I'm actually building 2 of these, so I had one already built or started. So what I've done, I just want to show you, is I've taken a 5/8 bolt. I cut the back off of the square tubing, turn that into a U or channel. I've taken my 5/8 bolt. Now we follow US LMRA rules, and the minimum spindle you can have is 5/8 diameter. So I use a 5/8 grade 3. I use grade 3 so that I can drill it and put a castle nut with a cotter key on it. So what I've done is I've heated up my 2-inch flat bar, bended it at a 90, and then I drilled a 1/2 inch hole in the top here, right there, and drilled another 1/2 inch hole for my heim joint. Now there's some distances that you want to kind of keep in mind as you're doing this. I measured from the center of the heim joint to the center of the threads. and that turned out to be 1 5/8. So I came over 1 5/8 and drilled my 1/2 inch hole. The reason for that is so that I could have some movement. I can show you on this one. I can have movement in and out. If you get that too far in, that won't go back in, there we go. That's your different caster camber angles right there. So if you drill this hole too far in, yeah, you'll be able to kick it out, but you won't be able to pull it in. So I went center, so I'm kind of split the distance and drilled that hole there. The other distance you need to keep in mind is this distance right here. So from your bottom of your plate to the center of that hole, so that you're compensating for this. I like to use shims. I put a couple washers on there, and that gives me the flexibility to shim it one way or the other if I need to. Haven't had to, but if I need to. The other distance that you want to keep in mind is when you're drilling the 1/2 inch hole in this part, you've got to have enough room for the head of the bolt so that it can pivot. So what I've done is it's 5/8 bolt, and I drilled an 11/16 hole. The reason I did that is so that I can kick this at an angle. Now with these front ends, what we do is we do this 10-10-10 angle. So we'll cut this here at 10 degrees, which I've already done, and then it will sit, let me move this and these. So it's going to sit on the axle beam about like that. Now if you don't leave enough room and make this flexible, it's going to put you at a really weird angle. So I drilled a bigger hole so that I could set this back up and bring it back 10 degrees so that the center of the spindle lines up with the center of the beam. So when this is all said and done and in place, it's actually going to be sitting about like that. And I don't know if you can see how that's, yeah. So this will be perpendicular, if you will, or level with it. If you don't do that, you're going to end up with some really crazy angle, and that's going to be amplified by your tire. So now the other thing that I've done, and I'll pull this one apart to show, is I took some 1 inch flat bar, drilled a 1/2 inch hole and a 3/8 hole. Now this actually goes right here. Get my washers back on there. Like that, maybe. There. Now that'll be my steering arm. So I'll weld this solid to this piece, and then as you move that, there's your steering right there. And that's all that is. Some other distances to keep in mind. The distance from the center of this to that hole. That distance right there. Because your steering arm is going to hook to that, and you want that to be perpendicular with the beam. Let me put this one on as well. So the other things that I've done with this, so I can show you, is when I'm building this, I start at the outside. I start at the spindle and work my way in. Now there's a reason for that. I need to know some distances. Now, like I say, we follow US LMRA rules, and the 2016 rule book says that the outer dimensions from tire edge to tire edge are 40 inches. So this whole assembly, once it's all done and set up, needs to be 40 inches from outside tire edge to outside tire edge. So what I'll do is I'll put this assembly together, just like so. There we go. And then what I'll do is I'll grab a tire, and the rim. And I'll put my spacer. Now, this spacer, this is just a 5/8 nut that I drilled the threads out. I'll slip that over here, and it's just a wheel spacer. I use this so that the bearing race will run against that instead of up against this mild steel. The other thing is, by doing it that way, you really do have a pretty good angle. It's pretty flush all the way around. And all it does is push the wheel off a little bit so none of this hits. So what I'll do is I'll turn and put this in like so. And that's pretty much how it's going to sit. I'll tighten it up. Now I've already done this. And I'll measure from the back of this plate to the outer edge of the tire. And that turned out to be 7 3/4 with these. So I'm going to round up to 8. So 8 times 2 is 16. I got to subtract that from 40. 24 inches is how long this beam's got to be right here. Now, one of the things I want to show while I've got this is you kick this off at an angle so that it won't rub. If you put that square with this, it's just going to rub on your tire. So what we do is we kick this off, and it's about 10 degrees. But I've found, talking with some people, that really what you want to do is you want to set this once the whole frame's together, or the axle's all together, and you want to point this so center of this and center of the other one line up with the center of the back axle at a minimum. I usually shoot for the center of the machine at the back, and that's the angle that you want to put that at. So as you look, this is it. This will be tied to your beam, and your tire would be turning left, right. So let me pull this out. You also want to make sure, and I'll cut this bolt here off so that it won't rub. But this gives me plenty of room with this extra spacer. Plenty of room for tire flex. I'm not going to hit anything, and it'll work. So there's my front end. Now, there's another part that I haven't showed you yet, and that is this. Once again, 5/8 bolt, which I cut the head off, and I'll explain why. You don't have to do that, but I did on this one. 2-inch flat bar with a 5/8 hole drilled and 2 3/8 holes drilled, and I kind of squoze these over to the outer edge so I'd have room for the tie rod ends. So what I'll do with this is actually going to be sitting about like that. This will be on the bottom, so you'll weld this bolt. Now I cut it off. You don't have to. I use a support bracket for this, even if I did use a bolt. Regular bolt, you'll weld that on the bottom of the axle. Now the axle is going to be sitting in the frame at 10 degrees. So you're going to want to compensate with that by pushing this 10 degrees so that it's level and true as the arm runs, so it's not on an angle that will bind. You can weld that head solid if you want. I like to have a little helper with it, add some extra. So what I'll do is I just bent this 1-inch flat bar. I'll set this guy right here. I'll kick that at about 10 degrees, so it'll be like that. And then I'm going to add this. And then I'll add this. Now from a top view, if you were looking underneath it, this would sit here. This comes off at 10 degrees, 10 to 12. And then my tie rod ends, I'll weld that to it. And then this will be my steering. So this connects to the steering wheel. There's also a pivot on the steering wheel. And as it gets moved that way, it moves left and right. It's just a direct steering. Really simple. So, but this distance, this is the bottom, from the center of here to this hole should match, that'll stay, this distance here on this arm from the center of the heim joint to this hole right here, so that these will run perpendicular. That's a pretty good show. Right there. So they'll run, those arms will run perpendicular to the beam. And then the reason I cut this head off is so that it's also not on a weird angle going up. It's pretty level this way as well as perpendicular to the frame. So when that's all said and done, this is the bottom. Let me roll this over, kind of give you another view. This will be sitting at 10 degrees. This will be level. And this would actually be sitting like this. And I don't know if you can see that very well. Try to change the angle. You can see how those would line up. Pretty much. So I think that's about it. Can't think of anything else right now. Oh, the next thing I'll do is I'll put this in a jig. And since I've already got this going, I'm gonna do that. So what I'll do is I'll set this up, and I made this jig. It's just, this is a trick another guy showed me. Is I've got this 2x4. So I'll set my beam here, and then what I'll do is I'll turn around, put this in here like that, take that spacer off, line that up with its 10 degrees, and then I'll set that like that. And I'll do the same on this side. Take that spacer off. Like that. Okay. I don't know if you can see that very well. Yeah, you can. So I'll try to roll it so you can get a good view. But basically what I'm doing is I'm setting this up so that I can tack this in place, and I'm leveling these outer spindles with where I want them on the axle beam. So if I roll this a little bit and hope it'll stay, you can kind of see how that, and all it is just some 2x4s and some plywood to shim it. But when I go to tack it and weld it, I'll be able to tape this down with some 100-mile-an-hour tape, duct tape, and keep these from creeping a little bit. And it allows me to dial these things in really, really close and very, very accurate. So anyway, I think that's about all I've got. Like I say, lots of reasons to build one of these front ends. I mean, if you're lowering your machine, you've got to do something with the front end anyway. And by doing it this way, gives you a little better performing machine. You'll be able to adjust the toe in, toe out, caster camber, and there are some safety advantages there, and there are some competitive advantages in doing that. So I think that's all I've got for now. What I'll do is I'll get this tacked up, and then I'll just go through a real quick walkthrough with it, show you what I've done. So we'll talk to you in a little bit.